Hello everyone, this is Jilin with Lab 3 of EC311. The board looks a little overwhelming at first, but the mapping diagram on screen now should help with that. On the VGA display, with reference to Lab 2, the operation code, inputs A and B, and the final result of the ALU are displayed from left to right in hex. The operation codes are exactly the same ones from Lab 2. The first thing I'm doing is incrementing input A one at a time via the top push button to the value 3. Similarly, B is incremented to a value of 7. I set the operation code to 1010, or A in hexadecimal, which is the code for addition, and we see that the final result is 10, or A in hex. Since we are in addition mode, toggling the CN switch adds 1 to A and B, giving us a hex value of B, which is 11. I toggle my CN switch off, and by pushing the left button, I reset my inputs A and B to 0. My next set of inputs are A equals 1 and B equals 4, and adjusting the operation code to 1011 for subtraction, I show that the final result is -3, indicated by the CL LED being on, and the hex value D, which is 1101 in binary, being -3 in 2's complement. The next set of operations all use the same inputs of A equals 1 and B equals 4, so I will simply put the operation code on screen as well as the expected final result. For the last operation, I return to addition and increment both A and B to 9. Since my final result is only 4 bits, I show that the CI LED is switched on when the result is greater than 15. Finally, I click my down button for resetting my VGA display. I want to first credit the sources for my debouncing push button and VGA display. The links to the sources can be found in my Verilog code files, which can be found in a linked GitHub repository. The first code snippet I would like to highlight is my decoder module. The new function of the decoder is to process the user's input via push buttons, where the user can choose between incrementing input A or B, saving the current input and switching the state to the other input, or resetting inputs A and B. The decoder outputs inputs A and B to be used with the ALU, as well as a button press LED, which lights up when one of the 3 buttons is pressed, and state, which is a LED that indicates whether A or B is currently selected. The clock input is simply the onboard 100 MHz clock, using the bouncing the push button and accurately registering the push button input. Inside of the bouncing push button module, there are 2 more modules, slow clock and D flip-flop, and are implemented according to the image on screen now. The slow clock is operating at 4 Hz. Back in the decoder module, I am checking for the positive edge of the slow clock in my always block, then checking if one of the buttons is pressed, and performing the appropriate operation if it was. Finally, the last assignment here lights up the button press LED whenever one of the buttons was pressed. The next module I want to highlight is the 2 hex ASCII code module, which is used to convert the 4-bit operation code, inputs A and B, and output of the ALU to their respective 7-bit hexadecimal ASCII equivalents. This specific formatting is needed for the VGA module. The VGA module is the last module I want to highlight. Within VGA, the VGA sync module is instantiated, which synchronizes the display and also outputs pixel locations to wires X and Y and outputs whether or not the pixel is within the active display region to wire video on. The actual text generation is rather simple. 1 text generation module instantiated per character. However, text generation does not actually display the character. What it does is save the position the character should be displayed, as well as the character to an array that is used to toggle whether or not a character is displayed. The text generation also takes the ASCII data inputted to it and outputs an array of ASCII data values for all the different characters. The actual ASCII data is provided by the ASCII ROM module, which is a block RAM of ASCII characters, and retrieval of the data requires hex ASCII codes previously discussed. Finally, the output RGB is what actually displays the RGB for each bit, and consequently forms the specific characters. So for my successes and failures, I believe I was relatively successful. I modified my input mechanism to working push buttons. For my design changes, I modified my decoder and added a ton of sequential elements. And the surprise change, I have a working VGA, so I think relatively successful in that area. I would have liked to see different VGA modes, but I ran into an issue with assigning the RGB values and just was not able to debug it within the time constraint. But overall, relatively successful, and yeah, thank you for watching.